All right, here we go. 6.2, number what, 13? All right, so it says the velocity of a 3 kilogram particle is given by v equals 8ti plus 3t squared j, and that's in meters per second with time in seconds. At the instant the net force on the particle has a magnitude of 35 newtons, so there is a point, net force at, what are we going to call it? We need to give the time a name. Let's just call it t naught. How about? Okay, so the net force at some time is 35 newtons. We want to find the direction at t naught. Does that make sense? The direction of motion. So what am I really looking for there, you guys? Anytime we talk about direction of motion, what should we think? What should we be thinking about? Velocity, right? Follow? Alrighty. So the trick then lies in, if I can figure out what TO is, then I can plug that into my velocity thing to find the direction, right? But I got to figure out what that missing time is, right? Follow? So, thoughts about how I might do that? Should I pause it? Sarah, you got an idea?
Yeah, I did.
Okay, get me started. What do you got?
I did net force like x equals. Oh wait, no. What do we have right now?
This is number 13. So.
Okay, wait, okay. I took the derivative and found the acceleration.
Okay, that makes sense to me because I've got an expression for the velocity as a function of time.
Yeah.
So if I can come up with an expression for the acceleration as a function of time, that acceleration is dependent on the net force, right? Okay, so that's cool. So let's see. So my acceleration as a function of time is the derivative of this. So what'd you get?
8 plus 6t.
8i plus 6tj. Yeah. Is everybody cool with that? That you just do your derivatives component-wise? Like you do your i's, you do your j's? Okay, cool. I like that. What'd you do next?
And then I did like the net force x, I guess, equals 3 times 8.
The net force. Oh, I see. Okay, this works. So I'm gonna do the same idea as what you're doing. I'm just gonna write it slightly differently. So that means that my net force as a function of time is just mass times acceleration, right? So what's 3 times 8i? 24i plus what's 3 times 6tj?
60.
Isn't that the same thing? This is your fx and this is your fy. Okay. So everybody good with that?
Yep.
This works. So now what? Made a triangle and solved for t, right? So here's my triangle. Let's see. 24, 18t, 35, right?
Yep.
So I'm looking at a squared plus b squared equals c squared. 35 squared equals 24 squared plus 18t squared. And solidify it, right?
All right.
How what?
There's no common denominator.
Common denominator?
Between those three to make it like.
Oh, I gotcha.
So,
I gotcha. Yeah.
like a 3, 4, 5 or something.
Yeah. It's sort of a 3, 4, 5 triangle, except for this stupid t in here, right? If the t wasn't there, it would be. But
Or you could find the angle and then just straight to 50.
yeah. Okay, so 35 squared minus 24 squared gives you a thing. Divide by 18, take the square root. Time gives you.
Mr. Hector, wait.
Yeah.
Do you have to have 18t quantity squared? Is the value?
Oh, yeah, sorry. Thank you. You're totally right. That was crappy notation on my part. Thank you. You're totally right, 100% right. Okay, so what does this give you?
1.42 seconds.
1.42 seconds?
Yep.
Good. All right, so now to find the direction of motion, we found our time. So to find the direction of motion, what do we have to do?
Tangent inverse. Oh, plug it into 18.
Plug it into the velocity function, right?
Oh. Oh, I did part B before I did A.
Gotcha.
Okay.
All right, so the velocity at 1.4 seconds is going to be 8 times 1.4, which is 11.2 I, right? Plus, I can't multiply 2.89 times 3 in my head.
4.2. 4.2.
Really? You forgot to square it.
No. Thanks, Jane. I get the calculator then.
Nothing, I'm trying to do math.
5.88.
What do you got?
5.88.
5.88, thank you. Oh. Cool, and then you can find your angle using the inverse tangent. Good. So my theta is going to end up being the inverse tangent of my y over my x, so 5.88 over 11.2, and it gives you whatever the answer was on the sheet, hopefully.
46.7.
Uh-oh.
Oh,
Okay, wait,
no,
wait,
that's for
I
part
did
B,
do.
Strackers.
I did.
Oh,
That's
shoot.
Part A.
Man,
You just gotta skip part A, but
Yeah,
A.
you skipped part
You
A.
showed the work, you just didn't take the cosine.
A says what's the net force? What?
The
At the
direction
instant
of-
the net force on the particle has a magnitude of... Oh, you're trying to find the direction of the net force. I'm sorry, I totally skipped. I'm sorry. Okay, so this is part B. I did skip A. I'm sorry, guys. I should probably keep the sheet in my hand. All right, so is everybody good with what I did here for B?
Can't you just take the angle from the previous
Okay,
drawing?
yep. And then to do part A, am I going too quick? Are we good?
No.
Everybody's happy?
Good.
All right, so to go back and do part A, we got to look at this triangle. Plug this time into this triangle and find this angle, right?
Or just use the difference.
Or just use the givens, right? Oh yeah, 35 and 24. You could do it that way too. Cool? So use a little bit of trig there and you can find that missing angle. Thank you, my bad. Are we good, you guys?
Yeah.
All right, 15. I've seen this problem on AP tests before.
It's like a multiple choice.
As like a multiple choice thing, yeah. Totally as a multiple choice.
Isn't this like a free
Yeah, because this is like a one step.
free
So if you struggled with it, make a note of how you do these kinds of problems. All right, so.
free